Hello and welcome to Unit 10. This is the last chapter in our class and we're going to try to wrap everything here together in terms of the problems that we might encounter when running a regression. This last problem we're going to be looking at is so-called heteroskedasticity. Hetero means different, skedastos means variance. It basically means that one of the assumptions in our model, that the variance of the error is constant, is going to be violated. Now, just as we did with multicollinearity and with serial correlation, we're going to be looking at the difference between pure and impure heteroskedasticity. Pure heteroskedasticity is the actual problem, where the variance of the error is changing either through time or either with relationship to some of the independent variables. The problem with that is that it's going to affect the reliability of our statistical tests. Impure heteroskedasticity is similar to impure serial correlation. This might be just a problem of coming up with the wrong specification for the model. In other words, it would be an easier fix if we can determine that what we're missing is simply a quadratic term in our regression. Once we have defined heteroskedasticity, and once we are sure that we're looking at pure heteroskedasticity rather than impure one, we're going to be looking at the consequences of it. What effect does it actually have in our regression, and do we actually need to do something about it? Then we're going to be looking at the detection of heteroskedasticity. There are multiple tests that can give us an idea of whether our problem is heteroskedasticity or not. And we're going to be looking at a couple of them. We're going to be looking at the classic test for detection of heteroskedasticity, the White test, and then we'll be looking also at more powerful tests like the Bruch-Pagan test. All of these tests are based on the same thing, auxiliary regressions. We're going to have to regress our model several times in a way trying to purge the errors that we encounter in each step of a regression, and then trying to figure out whether these auxiliary regressions actually present us with some information that has to do with the nature and magnitude of heteroskedasticity. One of the statistical tables we're going to have to learn to use is the chi-square table. You probably already remember your chi-square if you took an advanced statistics class. And if you remember even further, you probably remember that you used the chi-square table when you were trying to come up with hypothesis tests for variance of populations or samples. So, since we're dealing here with a variance or with a standard error, those chi-square tests are going to be somehow related. And lastly, we're going to be looking at remedies for heteroskedasticity. Sometimes some of the simplest remedies just involve changing the variables from levels to logarithms. Sometimes the remedy for heteroskedasticity is simply to combine our variables or to reweight our variables. And sometimes we really have no other choice but to come up with more powerful and robust ways to estimate our data.